let me go ahead and show you what I've put in Google Classroom for you for this week. So looking in our classwork tab in Google Classroom, week of January 23rd through 27th, that's today, do this week in Buzz with template. So this week we will have a program. What's due is 4.02 more decisions. That's our assignment for this week. And I've already made a template. So when you click on that template, here's what you use to turn in your assignment. It's got three parts. First, you write a program to move the turtle based on user's request. And we're going to look at this in the lesson. So create a menu that gives the user options for moving the turtle. The menu should contain letters or numbers aligned with movements like forward, backward, or draw in a particular pattern. Use at least one if, else, or elif. This is what we're going to learn today. Statement in this program, and it should be used to move the turtle. A loop is optional. You can put a loop in there. It's not required for the program this week. Use one color other than black, and be sure and write the pseudocode. So here's where you paste your pseudocode. We got that for you. Then you code the program using idle, Python idle. Make sure you put your name, today's date, and a short description of the program. Make sure you use all the indentation, white space, and use meaningful variable names. But here's an example of what you might have as the output. Just an example. Like try to move the turtle to the pond. Like there's the pond, there's the turtle. And this says you can, here's the menu. You can put F, B, L, R, Q, and it'll move the turtle forward, backward, left, and right, and then Q quits the program. So that's a pretty clever one. Now here's another one over here. Well, it's the same one, but it's at the end when they moved it. They move it this way, that way, and the turtle is in the pond. So you put your actual pseudocode, your actual program code here. Your pseudocode goes up here. Your program code goes here. And then, of course, here's your review questions at the end. So make sure you paste your pseudocode in, you paste your code in, and you answer the 4 questions before you submit this in Buzz. So there is your template. But let's look at this week's lesson so you can learn how to do these if, else, or elif statements. And some of this, if you got some of these statements and you're trying to figure out how they do, and you don't want to look through the lesson, or you look through the lesson to understand it, you could always do a Google search, Python if else. And you do that, and it'll pull up some other places that'll help you with that. Here's one that gives you examples of how to use it. Python if else statement. Gives another video to help you understand if else statements. So gives you an example, if else, or if elif else, which we're going to look at today. But you can find examples online of how to use these statements other than just in Buzz. So just you remember you've got other resources to learn what some of these do. And if it's some past stuff you don't remember how to do it, you could also Google that up and get some examples and help understand that better. All right, there's where you turn in your program. So let's look at the lesson for this week. The power of if, right? Not all decisions are one-dimensional. In fact, most decisions are not one-dimensional. So, if you're taking a walk, if your walking path is closed, you can skip your walk, or you have other options. You can do something else, take another path, do yoga, climb a tree, whatever. So you've got options. So we're going to learn about if, else, and elif statements and explain their uses and then use them to make decisions. So let's go through page 2. So with if statements, if the condition is true, you take an action. We looked at that some in our last lesson last week. If it's false, you do nothing. For example, if you win a race, you get a medal. If you don't, you get nothing. You didn't win. However, more often than not, you'll want to write programs that can handle multiple decisions. This is where the if, else, and the elif statements come in handy. So look at this. Here's the if, else statement. With if, else statements, if the condition is true, you take an action. But if not, you take the else action. If it's false. So if it's true, do this, else do this instead. So if you win a race, you get a medal. If you don't win, you get a participation ribbon. The elif statements allow you to check multiple conditions. A lot of times we need to check more than one thing. And as soon as one of them's true, then it'll take that action. So if you come in first place, you get a first place medal. If you come in second, you'll get a second place medal. If you come in third, you get a third place medal. Else means if none of those are true, then you just get the participation ribbon that showed you ran in the race. So that's a little more realistic because they'll get first place, second place, and third place medals, and they're different medals, so it's not just one if statement. So here's some flow charts that kind of describe the if else, and the elif statements. So let's look at the first one here. If, coming into this condition, if it's true, it goes down to whatever code that we execute and then continue on. If it's not true, it's false, we take a loop and we go around that code. We just don't do that, right? We go around it and continue on with the program. That's the if statement that we looked at. Now we have the if else. Again, if it's true, it just executes. Oh, it moved the true over here. I'm sorry. It switched. If it's true, it goes over here and does this code, executes this code right here, and then continues on. If it's not true, if it's false, it goes down and has some different code it executes. So if it's true, do this. If it's not, do this. Either way, continue on with the program. Now here's what the elif, just to give you a visual of how the elif works. If condition 1 is true, the first if statement, if this is true, then do this block of code and then skip everything else and continue on with the program. But if that's not true, check to see if this condition's true. And if that one's true, then we'll do this block 2 of code and then skip everything else and go on with the program. Or we can have another elif that says, all right, well, if condition 1's false, condition 2 is false, check condition 3. And if that's true, then we'll do block 3 and then skip everything else and continue on. But if condition 3 is also false, then I want you to do this before continuing with the program. And we're going to look at that as some practical examples here in just a moment. All right. Life is getting pretty boring if you only had one option for everything you want to do. That's why you got to make choices. So if you want to play a game solo, you choose to play offline, or else you can select the online option on your video game, right? Python is a pretty easy setup for the if else. It uses Boolean logic, again, George Boole, to determine whether a condition is true. And if it's true, then it executes whatever's in the if statement. If not, it moves on. So here it says age equals, their equal signs really don't work here, but the age equals integer input. What is your age? So this is asking the user of the program to enter their age. Then it checks if the age, which is the variable they use right there, is greater than or equal to 17, print, enjoy the movie. So this is one of them rated R movies, no one under 17 allowed. Else means if your age is not greater than or equal to 17. So if you're less than 17, else, print, please bring a parent or guardian, because you can't go to the movie alone. You have to have parent or guardian if it's rated R. So in this code, you're asking the user to enter his age before buying a ticket with a movie. Right? This movie has age restrictions. So using the if statement, it'll compare the age with the number 17 and then use Boolean logic to figure out which statement needs to be printed. If it's 17 or older, enjoy the movie. If it's not, please bring a parent or guardian. So with if else statements, Python will always take some action. Either it'll execute this if that condition is true, or it will execute that if it's false. So it's going to do something. It's either going to do the if part or it's going to do the else part. So that's important to remember. With the if statement, it just checks if, and then if it doesn't, it skips it and goes on. But now since we have the else, it'll always do one or the other. So make sure you know what you want it to do. So here's some practice with some if else statements. All right, so I'm gonna copy this to give us a little more space to see this and bring it up in just a Python window that I can make bigger here. Well, it didn't really make that part bigger, did it? That's all right. All right, the if-else statement. So here it defines our main, there's our main function. We're assigning the value of 20 to the variable x and assigning the value of 30 to the variable y. It's going to print this statement first, facts about A and B. If x equals, remember the Boolean logic uses two equal signs to check equal because we use the one equal sign to assign a value to a variable. So if we're using a conditional statement, we're going to use two equal signs. If x equals y, print x equals y. If that's false, it goes to the else statement and it prints x is not equal to y. And that's the end of the program. 20 and 30. So we would expect it'll check this value, it will find it's false, and it will skip down and print this. So let's run the program. There it is. X is not equal to y. So let's change this, make them both 20. Now when it runs, it should find that this condition is true and print the first statement. So let's clear the output, run the program. X equals y. It just simply does a Boolean check to compare this condition. Does x equal y? True, false. All right, let's go to slide number 2. All right, I'm going to copy this code again and put it in another window. All right, the if else statement. Here's our main. Define main. Show equals. So show is a variable name. And we're doing an input statement. So the user is going to have to input when is the movie, afternoon or evening. So it tells the user what to enter. Either enter this word or enter this word. If, and now let's check what was entered. If show equals afternoon. If they entered afternoon, the ticket will be $5.50. Else, the ticket cost $8. So print the cost of the tickets. That's one of those things where they give you an afternoon matinee price. So let's run this program. When is the movie? Let's type afternoon. Cost of the tickets, $5.50. Because it said this was true. Now let me point out, if we run this program and I type this, afternoon, notice I'm using a capital A. We read that, we say, yeah, okay, that's afternoon. It says the ticket's $8. Because to a computer, afternoon with a capital A is different than afternoon that's not capitalized. Computers look literally character by character to see if it's identical. And a capitalized A is not the same as a lowercase a. So the computer says this is false. It does not equal afternoon. So as far as this program goes, if we entered anything, when is the movie? Hippopotamus. Just say tickets are $8. It's only checking to see if it equals exactly these characters, afternoon. Anything else, it's going to put $8. But it is good to have in your input statement, what are we looking for the user to enter? And we tell them very clearly, either enter afternoon or enter evening. Evening. $8. Has to be exactly these characters for it to do otherwise. That's one of the limitations of a computer, is it literally can only look at the character. It doesn't understand context. It doesn't read the word and say, oh, well, that's the same word. Because if we put afternoon, we put a space in there. It's afternoon. Yeah, it's $8. When computers aren't that smart, they can't read and understand. They only check exactly what you type. Let's look at the next one. All right, we're going to copy this and put it in another window. So we've got a bigger window to look at. All right. From random import. Now this is interesting. So we're importing a new function. You know, we do math import, we do turtle import. This is a random import. So we've imported some new function here. Define the main function. So here's our main function. Flips. So flips is a variable name. integer input. So we're having somebody input again. Enter the number of coin flips. And we've said this is going to be an integer because we're not going to flip a coin 4.5 times. It's either 4 or 5. It has to be an integer. So somebody's going to enter an integer, and they're not going to enter a decimal because it says enter a number of coin flips. That's an integer. And so we start out saying the variable heads equals 0, the variable tails equals 0. And 4 count in range. Okay, so this statement, remember, this is a for loop, and it's going to count and do up to this many flips. Remember, it starts counting at 0. So if the user enters 10 as the number of coin flips, it's going to put 10 flips in there. It's going to count from 0 to 9 and going to stop at 10. Result equals random. Okay, and they didn't put any number in there. They just left it there. So that will generate a random number between 0 and 1 as a decimal. Because we've imported this random function. And since we imported a random, we can use it here. Result equals random. Now, if we put a number in there, it's going to go between 0 and that number, like 50, 0 to 50. But we just want to go between 0 and 1 because what we're checking is if the result, which is this variable right here, is less than 0.5. So that's in the middle, right? 0 and 1.5 is in the middle. So we're saying randomly, if that random number is less than a half, then we're going to say it's heads. Heads equals heads plus 1. Add 1 to the count of the number of times we've gotten heads. So it'll do that. If the first number is 0.4, it'll add 1 to heads, and then it'll go back and do the for loop again because we haven't hit the total number of flips yet. So this time we'll say it's 0.8. It'll check. This is false. This is false. So it'll go to the else statement and adds 1 to the tails. We're not up to the total number of flips, so it will go back and loop again, and it will continue to loop through here until it reaches that 10 count that the user put in. At that point, it continues on. It'll get out of the loop. That gives it an out. It has to be able to get out of that loop somehow. So it keeps adding 1 to flips every time. Then it goes down to prints. Prints a blank line first. Then it prints coin toss results. Then they have them print this line underneath there. And then it prints exactly this, heads, colon, and a space. And then whatever number heads ended up. Then it'll print tails, colon, space, and whatever number tails ended up. And it'll end the program. So let's run the program. Let's say number of coin flips. Let's just do 10 to start out and hit OK. And it got 5 heads and 5 tails, which is kind of what we would expect. At a random distribution, you should get about half of each. Let's run it again. Let's do 100 coin flips. Now we see a little bit of variation because you flip it enough times, it won't exactly. It always should be close to 0, but it won't. And this is kind of pseudo random. A computer has a hard time randomizing. I mean, it's random, but it's not really random. So, but this is a good representation of it's either a 50-50 choice. It's either less than 0.5 or it's greater than 0.5 or equal to 0.5 or greater. So there's only 2 choices. And that's about 50-50. We clear that and run it and say, let's do 10,000 flips. It is. It's close to 50-50. But there's ended up 19 more tails than being exactly half. So it's 38 more than heads because 19 went one way instead of the other way. So that's a way to use this random portion to put a randomization into your programs. So play with that. If you have trouble with that, you can always Google it again if this didn't help you enough. But look at these examples in these programs to figure out how to do some extra things in your program. So let's look at this last one. Oh, here's the import turtles because this is going to relate to our assignment. So let's bring that in here. Okay. Again, we're bringing in the random function. We're defining our main function here. So here's our main program. Flips. Oh, wait, did I get this? I didn't get this changed. Wait a minute. I don't think I got the other one copied. Hold on. Copy. All right, now let's go back and do this again. All right, here we go. All right. Oh, yeah, we got a lot of stuff here. In fact, let's do this so we can look at more of it at one time here. I want to paste it in here so we can look at a lot of it at one time. And then we'll go back and we'll run it. But look how long this program is. All right, so we have the if-then statement. So the if-else statement, import turtle. So we know we're going to be drawing some graphics because we've imported the turtle function. Now, here's where we're defining functions. Remember, the last thing we did before Christmas break is we learned how to define our own functions. Before that, we usually just use the main. We always define the main function, and that's the main portion of our program. But on this program, we are defining different functions. Here, let me get all these things out of the way. They drive me crazy. Ignore all. Get all those little red underlines out of the way so we can look at this. All right. So we're defining a function called draw face with a variable of t because we're using our t for our turtle. Draw face. So this function draws a face. So making yellow, taking their pen up, moving the pen to position 0, -30. Remember, you can play with those numbers to figure out where on the screen you want that output to be. They're putting their pen down at that point and begin fill. So everything is drawing, it's coloring it in. So it makes a circle that is a length of 80, with a diameter of 80, and it's filling it in. So it makes a circle at this position, a yellow circle, and fills it in. So that's what the draw face function does. So then they go to another function, and we're doing draw eyes. So this function draws an eye. So we're making it blue, moving it to position 30, 65, filling it in and making a small circle of 15 and ending that. Then it goes to -30, 65, and it draws the other eye. Same size, 15. All right. That's the end of that function. Now we're defining a function called draw frown. This function draws a frown, making a red frown. Here's the width of the pen. We want to make the pen wide to a 10, starting at this position, goes left 90, puts the pen down, begin fill, makes a circle here, end fill. This one draws a smile. It's a red smile with the 10 again at this position, right? So someone's played with it to figure out what length they want it, what position they want it, making their circle 180. So it's not doing a full 360. It's doing a 180. This one's doing a 180. So it's only really doing half a circle. That's how many degrees it's doing. So those are the four functions it's defined. It defined a function to draw a face, draw eyes, draw a frown, draw a smile. 4 different functions. Now it starts the main part of our program. Here's our main function. T equals turtle.turtle, right? That means, okay, telling Python, we're going to start drawing. We defined all of our T's up here, all of our functions with T's. So we tell it to do a speed of 10, and we tell it draw face T. That tells it to go up here to this function that we have already defined and run this function, draw face. So it'll run this function at that point and draw a face. Okay, then it draws the eyes. So it goes up to that draw eyes function and it will draw the eyes. Then it'll stop and it says smile equals input. Do puppies make you smile? Y/N. So again, we're telling the user exactly what to enter, either a Y or an N. And then it will use an if-else statement. If smile equals yes, if they put in a Y, if the smile equals Y, and that's what the variable is assigned as a Y, then do the draw smile function. Otherwise, if that's false, it's not a Y, draw a frown and end the program. All right, so this is a clever use of making the turtle draw different things, but letting the user decide how it ends. So let's go over to our actual Python program and run this now. All right, so it's drawn the face and started the eyes. It stops. Do puppies make you smile? Let's say why. Say yes, they do. Put in a why. So it draws that 180-degree circle and fills it in red. So it's got 2 eyes and a smiley face and ends the program. Notice we don't have a frown because the if-then function, when it got down there and checked, this was true. So it only did the first part of the if. It did not do the else. So let's clear that and let's run the program again. And let's say N. No, puppies don't make it smile. Oh, it did the sad face. Now, see. Oh. So, clever use of the if-else statement in their graphics to affect the outcome, to change what the outcome is based on what the user inputs when they run your program. Note again, when we run the program, do puppies make you smile? Why, yes, they do! Exclamation point. We're still going to get a sad face because we didn't put a Y. It's just looking for this one character. We typed in a whole bunch of stuff. So again, it doesn't understand by reading our sentence. See, we get the sad face. It does not understand. It's simply looking for that Y or N. So that's why it's very important in an input statement, especially an input statement you're going to use with an if statement, that you tell the user what the choices are so they can enter what the computer is looking for. You have to put that choice there. Y or N. Actually, you just really need the Y or whatever. But so that's a key part of that. All right, let's look at the last page of our lesson here. Okay, here's the thing. Sometimes you need more than 2 options. So we're going to get into the elif statement. Okay, think of elif as a combination of the words else and if. Elif, else if. So in an elif statement, you can allow for a wider range of possibilities. So here's an example. Grade, input, what is your grade? Okay, so it's an input statement. They're going to hear what the grade. If it's an A, it says if it equals an A, print excellent. And if that's true, it'll print excellent, and then it'll jump all the way to the end and continue with the program. It'll skip all these other ones. If that's not true, then it says else if. So if that's not true, check this. Is the grade equal to a B? We'll print good job. But if that's false, check the next one. Is the grade equal to C? Print nice start, but try to study more next time. If it's not an A, it's not a B, it's not a C, then it will automatically do this last statement. Print, please reach out to your teacher. So you've asked the user to input the grade. It's going to check A, B, or C, and it will print something depending on which one of these statements is true. And if none of them are true, it'll go to the last else statement. So with elif statements, Python may or may not take any of the actions, right? Until this. This is the default thing if nothing else is true. It may do this, it may do this, it may do this, but if none of those are true, this is the default. This is the thing that it will do if nothing else is true. So remember that when you're using these. So let's check our understanding of elif statements here. All right, again, let's copy this over and run it over here. All right, find main. A equals 10, B equals 200. So this is another facts about A and B. If it's equal, print A equals B. Else, if A is greater than B, then print A is greater than B. Else, if A is less than B, print A is less than B. And if all of those fail and none of those are true, print there was an error, which there must be an error because A either has to be equal to B, greater than B, or less than B. There's really no other choices. So if something happens in your program where none of those are true, there is an error somewhere because that's our only choices. Let's run that. Facts about A and B. A is less than B. Sure, because it's only 10 and B is 2000. If we want to add 2 zeros and make it 1,000, now A is greater than B. We want to make this 1,000. Now they're equal, so it should tell us that A equals B. Now you can go ahead and play with these programs. You can go ahead and change them here too. You know, we can make it 100. It'll still be less, right? A is less than B. Let's look at the next option it gives us. How big this one is. So we'll try it on this screen first. Okay. Here's the whole program. Define main. Print who won the game. And so your score as a variable is assigned the value 9520. My score is assigned the value 9905. So if your score is greater than my score, then print you win. Else, if your score is less than my score, print I win. Else, let's see, this is an else if. So if neither one of those are true, then this is guaranteed to print we tied. Okay, run the program. Who won the game? I won. Because my score was bigger than your score. But now if your score is 9920, you win. Because you beat me by 15. But we can change them to be the same just to test. And when you run a program, you should always test it. Who won the game? We tied. So we made all three of those true one at a time. You win, I win, we tied. And we was able to get all the outputs of that. The other example it gives us here, and remember, you can go ahead and change these things. Here's another turtle one. So we're going to put that on this page where we can see all of it at one time. Okay. Woo. Yeah, this is a long one. All right. Again, let me get rid of all of these things. All right. The elif statement, import turtle. So we're drawing again. So now we're defining functions. We're defining the sunburst. Sunburst T, move to this position. All right. So take the pin up, make the X 150, the Y 130, and set that as our position. So move the pin to the position 150, 130. Set heading at 270. That tells it what direction to head, 270 degrees from that position. Put the pin down and make it gold. And now draw a star. And it does some little fancy stuff here. Set position at this part right here. So X changes. One starts at 150. And then it subtracts each time X divided by 1.750. And this subtracts from the Y divided by 12. And it's going to do 40 loops from 0 to 39. 40 loops where it moves forward 60 and then turns left 130 degrees. And so with that, it's going to draw a star. So that's what they call the sunburst, right? And again, you can play with these numbers to see what it would do in Buzz. Play with those numbers, see what it changes. But that's defining the sunburst. Now let's go to define the spiral twist. So this draws an eye, it says. So it makes blue, moves it to this position, puts the pin down. This does from 0 to 75, but it counts by twos. So 0, 2, 4, 6, 8. And it moves forward whatever X is. Starts by not moving forward at all, 0. Then it'll move forward 2. It'll move forward 4. So each time it's getting longer and longer because it's using that X as the variable on how far to move forward. And then it turns left 91 degrees. So that is the spiral twist. It blew. Then it defines another function called doily. This draws a frown. It says, so it moves it to 45 at 5, turns left 9 degrees, puts the pin down. And now this has got a loop inside of a loop. So it's going to do this loop twice, A in range 2, B in range. It's going to do this 5 times. Going to make it green, make a circle, make another circle, move forward. Then it's got a loop inside of that. It's going to do 3 times where it goes right 80 and forward 5. Again, change these numbers to see what they're doing. Somebody's played around to figure out exactly how to draw this. And now we have another function down here. We've defined all those. And this one's print menu. So this function prints a menu to the screen. So here's the menu. What's it to print? Exactly. Put everything in quotes. So this should be exactly what it prints on the screen. Now we finally get to the main function. So we defined all those functions so we can use them in our main function. T equals turtle.turtle. We're going to do a speed of 10. We're going to set the initial choice at -1. So notice it's not going to equal any of these because we're setting it at -1. So it says while the choice is, remember this exclamation equals, that means not equal. Exclamation equal means not. So while it's not 4, print the menu. So it'll go up and it'll execute this print menu. Then it says input. Look at the menu. Which item would you like to draw? 1, 2, or 3, and select 4 to exit. So then here's the else if statements. If it's choice number 1, execute the sunburst application that we defined above, that function. Else, if that's false, check and see is choice equal to number 2. If it is, then execute the spiral twist function that we defined above. If that's false, check to see if it's number 3 and execute the doily function. If that's not true, then check to see if it's choice equal to 4 and then print thank you for drawing today because that exits. It doesn't execute any of the functions above. It just prints that and it will exit and get to the end of the program. Else, if it's not 1, 2, 3, or 4, oops, an invalid option is picked. Please try again. So there's our if statements. And this will go back up again. And see. So let's see. Well, that should end it also. Oops, an invalid option picked. Try again. All right. So we've got all of this. Let's try it actually in our code. Delete that. Paste in our new stuff. All right. Let's see how all this actually works. Now, here's the problem. The first time you run it, it didn't print the menu. So let's just choose 1 because it does tell us again what our choices are, 1, 2, or 3. So we'll choose 1, not knowing what 1 is. And we hit that. Now it's running that sunburst. See that? That's that sunburst. That's the loop it did like 40 times or something. How many was that? Sunburst loop. Yeah, 40 times. So it took 40 times, moving forward 60 and then turning left 130 degrees to draw this sunburst. So now it comes back to the menu because I didn't hit 4. So it's going to continue through the menu. Let's do 3. 3 is the doily. So see what the doily looks. It moves and draws the doily over here. That's the one that has the C inside of the B inside of the A. So it's doing all kinds of different drawing in there. Let's choose 2. That's one where it's using X. You know, it changes X by 2 each time. It starts at 0, then it makes it 2, then it makes it 4, then it makes it 6. So that's how long it's going each time. 6, 8, 10, 12, 14, 16. That's why it's getting a little longer each time and making this little thing. Let's choose a number that's not there. Like 12. We choose number 12. Oh, if we go down, because each time it's doing a menu, it just comes right back to it. If we exit, we can see it, excuse me, keeps going down. Every time it prints the menu, because in that loop, print menu is inside that loop. So it will do that every time. As long as the choice is not 4, it prints that menu every time. So it printed the menu every time till it got down to oops, an invalid option was picked. Try again. And then it printed the menu again. So let's see what happens if we take that menu and let's move it up here above. Move that up here above it. Let's see if that will make it only do it once because we took it outside the while loop. So let's clear output, run program. Does it do it at all? Oh, there's the menu. We chose number 2. Now, if we choose number 1, okay, it did not print the menu again because it's outside the loop. So the menu just stays on the screen And we can do this over and over again without having a whole bunch extra added onto the screen. Let's see what happens when we choose one we've already done. I guess it will draw it over it because it doesn't move it to a new place. If I do 1 again, oh, it's drawing it on top of itself because I've already drawn it. It's just drawing it again on top of itself. When I choose that wrong option, let's choose option number 5 this time when it comes up. 5. Oh, it didn't do anything. It didn't even print our error, I guess. Oh, it didn't until after I got out of the loop. When I got out of the loop, then it printed, oops, an invalid option mistake. Let's try this one more time. Let's do it this way. Let's choose the wrong option twice in a row and see if it prints anything on the screen. 5, 6. No, we can do it a bunch of times. Until we exit, it's not printing it. That's just something in the order it does things. So, all right. So that gives you an idea on things you can do for our program, because that's the last example it gives, slide 3 of 3. We go over here, all it has is the assignment and the rubric. Remember, you can always check the rubric to see how's this going to be graded. The program design is worth up to 10 points, anywhere from 0 to 10 points. That means it has all of the elements. It's got your name and date. It explains the purpose. You've indented it correctly, and you've used good variable names. Then up to 40 points to make sure you've got all of this. Your code matches your pseudocode, right? You write your pseudocode to make your plan first. You've defined a main function. You've got the menu that prints. You've got an if else or an elif statement, and the turtle functions are used. So you do all of those. That's worth 40 points. 30 points that it runs correctly with no errors and produces what it's supposed to produce. And then 20 points for those questions at the end. So if you don't fill out those questions, you lose 20 points right away. If you don't have the pseudocode, did you lose some points here because your code doesn't match the pseudocode because there's no pseudocode to be shown. Right? So to get all the points, make sure you've got all the elements. The assignment template. This is the same thing I've got loaded in Google Classroom. You're going to create a menu, gives the user options for moving the turtle. This program we looked at certainly gave the user options for moving the turtle. I got to choose what it drew. It was my option on what it drew. So as the user, that did that. So use at least one if else or elif statement. You can put a loop if you want to. It's not required, but with turtle, you probably will be making some loops to draw some stuff. Don't use black for everything. Use one color other than black. You could use more colors, and then make sure you have the pseudocode. The pseudocode. So what would the pseudocode look like for something like this? Well, let's see. Let's say we were going to write pseudocode. So we're going to say import the turtle function, define sunburst, and then I'm going to define my, what I call it there, define my spiral twist. I'm going to define all the other, the doily. Print the menu 1 through 4. 4 is exit. So I'm just planning it. User inputs choice from menu. If else statement to print user choice in program or in main. That's some pseudocode. Not real code. That wouldn't run if I put that in Python, but it's not supposed to. This is fake code, pseudo, false. But it plans it out. So I know what I'm supposed to do. Okay, let me enter a turtle function. Oh, I got to go to find my sunburst. So then I can write all this code. Okay. And I may need to play with that in Python to make sure it draws exactly what I want to draw. It puts exactly where I want to put it. That it goes as far as I need it to go. Is that the right length for my starburst? Is that the right angle to turn at? All right. So after I get done with that, it's like, okay, what was I going to do next? Well, let me go back and look at my plan. Oh, next I was going to define my spiral twist. So let me go define my spiral twist. Then I'll go ahead and write that code. Okay, now what was I doing next? Oh, the doily. Right. Oh, now I got to print the menu 1 through 4. So make yourself a plan, and that's what you include when you turn it in. You're writing pseudocode. You can make it more detailed this if you wanted to. You can decide, oh, this is going to be yellow. Oh. You can decide length 90, turn left 130 degrees. You can put that in your plan if you want to, and then you can change that if you decide to change that. Make this blue. Okay, so you can put as much as you want to in here when you're planning it. Just make sure your code matches it and that you have a plan. Again, none of this would actually work in Python because I'm not writing code. I'm writing fake code, pseudocode. So that's a nice review of the if-else statement. Any questions? All right, this is the first week of our normal virtual schedule. So today's the only required day. I will be putting the grades in before tomorrow's advisory since you're doing your first grade check tomorrow. So after I get the grades entered, you'll know whether or not you're supposed to be here Wednesday and Friday. Oh, it's an A day. I got to change that. It's an A day this week. So if your grade's below 70, then you need to be here Wednesday and Friday. If you want to start writing your code and you run into problems, you can always come to class Wednesday, even if your grade's above 70, and you can bring your code and say, hey, Mr. Brock, I'm having an error and I can't figure it out. Great, bring it to class. Let's look at it. Let's figure out your error for you so you can continue working on that, getting it right. You can always do that. You can always email your code to me and say, hey, Mr. Brock, this got an error and I can't figure out what the error is. I want to get all the points, so I don't want any errors in it. Great, send it to me. Let's play with that together. So, all right, that's everything for today. If you got questions, throw them out there. Otherwise, I'll see maybe some of you Wednesday or Friday. Otherwise, next week. Bye-bye. Thanks.